The Nancy Grace Roman telescope is one of the most exciting projects NASA has going on. It will be able to image more of the sky in 1 year than what Hubble has done in its entire life. If you're watching this when it's uploaded, it's scheduled to launch at the end of August of this year. It will help us find more exoplanets than any other telescope ever made and answer some of our biggest questions about what exactly dark matter and dark energy actually are. The Nancy Grace Roman telescope is named after the first chief of astronomy at NASA. She's known as the mother of Hubble. She was pivotal in the early days of NASA and laid the foundation of what is today. We could do an entire video about her, but we'll leave it there for now. Every decade, there's a specific committee that gets together and decides what objectives are the most important. In 2010, they decided to make this telescope the highest priority. Its goal was to find exoplanets and observe the universe to gain insights into what exactly is dark energy and dark matter. In 2012, they got very lucky and were given 2 Hubble-sized mirrors that a spy agency didn't need anymore. Despite the telescope almost getting its funding cut on 4 separate occasions, the telescope came in under budget and ahead of schedule. It's currently sitting at the Kennedy Space Center in Florida waiting to launch. The mirror is built for width. It will scan the sky faster than Hubble ever could, and its maps will hand telescopes like Webb their next targets. It's not meant to rival the Hubble or Webb telescopes, but enhance their current capabilities. It will fly at to Lagrange Point 2, which is where the James Webb Space Telescope also likes to orbit. That way the Sun and the Earth aren't obstructing its view. Unlike Hubble that scans relatively small portions of the sky at a time, the Roman will scan massive areas. It will be able to scan in 1 year what the Hubble could do in its lifetime. And the coolest part is that all the data is open and free for the public. Normally the mission's own scientists get exclusive access for a while first. With Roman, there's none of that. As soon as it hits NASA's servers, you can download and sift through it. Dark energy was discovered in 1998, but we're still not sure what it actually is. For decades we assumed it was constant, but recently there was a study that found hints it may have been weakening, although this hasn't been accepted as consensus by the scientific community. The Roman telescope will help shed some light on it. There's 2 main ways it will try to measure the influence of dark energy. The first is measuring thousands of Type 1a supernova. These all explode with a known brightness, so how dim they look tells us how far away they are, and that lets us track how fast the universe has been expanding. Basically a modern version of what we've already done. And the second is a lot more advanced. It will measure the weak lensing of galaxies, basically small distortions in the shapes of galaxies caused by gravity. If these agree with the DESI study from last year, then we will have a monumental shift in our understanding of the universe. If it disagrees with DESI, then our standard model still holds up. Either way, the scientific community will be eagerly waiting for the results. Now for the exoplanets. Almost every planet we found so far was discovered by watching a star dim as a planet passes in front of it. It works, but it misses a lot of them. It mostly finds planets that orbit close to their stars. The outer parts of the other solar systems, where our own gas giants live, are still mostly blank on the map. That's the gap Roman is going to fill. It does this with something called microlensing. When one star passes directly in front of a more distant star, its gravity acts like a magnifying glass and briefly brightens the background star. And if the closest star has a planet, the planet adds its own little spike of brightness on top of that. The catch is that these alignments are extremely rare, so Roman will watch over 100 million stars near the center of our galaxy. Simulations predict it will find around 1,400 planets this way, some as small as Mars. Some planets don't orbit anything at all. They got ejected from their solar systems long ago and now just drift through the galaxy. A normal survey has no way of finding these, but a rogue planet still bends light when it passes in front of a star, so Roman can actually count them. Estimates range from a few hundred up to around 1,000, and the craziest part is what Roman finds by accident. Just from staring at all those stars, it should also catch somewhere between 60,000 and 200,000 normal planets as a side effect. That's around 10 times more planets than we've found in all of human history. Roman has one more instrument on board called the Coronagraph. Technically, it's a tech demo and not one of the main science instruments, but it might end up being the most important thing on the whole telescope. The problem it's trying to solve is that planets are absurdly faint compared to their stars. In visible light, a planet like Jupiter is about 1 billion times dimmer than the star it orbits. Every direct photo of an exoplanet we've ever taken is a young giant planet that's still glowing from its own formation. Nobody has ever photographed a mature planet shining in reflected starlight, like the planets we actually live next to. The Coronagraph blocks the star with a series of masks, and then uses special flexible mirrors that adjust themselves in real time to cancel out the glare. Nothing like this has ever flown in space before. If it works, it should be able to image planets around 100 million times fainter than their star. But the real goal is what comes next. NASA's next flagship telescope, the Habitable Worlds Observatory, is supposed to take pictures of Earth-like planets directly. Roman's Coronagraph probably won't find alien life. Its job is to prove the technology so that the next telescope can. If you like this video, it would mean a lot to me if you hit the like and subscribe button. You can support us further on Patreon for early access to content, selecting future topics, and Patreon exclusive videos.